There's only going to be one take. Always. All right, we are rolling. Good. So we do need to get this.
Yeah.
This is in calories per mole. And we want it in joules per gram. This is not going to be a hard conversion if we organize our data correctly and we know our unit equalities. But we should know our unit equalities. First of all, what is the calorie to joule unit equality?
4.0.
One what equals what?
1 calorie equals, no, not 1 calorie. Yeah, 1 calorie equals 4. How many joules?
0.184.
Oh, yeah, right.
4.181 joules.
Oh my god.
Okay.
You were right.
That is correct.
I was close.
Well done. And now I can organize it properly to leave me with joules. We should all be taking notes on this. At least pretend,
Including those of you at
pretending
home.
to take notes at the
That's
very
right.
least.
Elijah, I know you'll be watching this video.
It's a lot easier rather than pretend just to actually do it.
And Julia.
And that does give us our desired unit in the numerator. We're very happy about that. And although this is not a memorized unit equality, we should be able to find how many grams are in a mole pretty easily. And how do we do that? We do need the molar mass. We do need a periodic table. We do need a calculator because we need to add up 56 plus 56 plus 56 times 64. Or not times, sorry, plus 64. We need to add up the molar mass of this.
232.
Iron is 56. Is that 3 of them?
232.
232?
I just said that.
No, I said it.
Lie.
64?
Yeah, 4 oxygen, 64. How much is it?
232.
I said that.
We have confirmation.
Yes.
Of course, Russell
All
has to
of
confirm
it.
it.
Russell said first.
And again, it is important. Some of you don't do this still. It is important to write out your units and what they actually are. I was born in the dark.
Oh.
You only inherited it.
That's on
That's
video.
bad.
All right, how do I organize this fact so that I'm actually left with
I
grams?
thought you watched that. That's Batman. That's Bane from Batman.
Oh, I hate Bane. Sorry.
How do I organize this fact so that I'm left with grams in the denominator?
You have to cancel out.
How do you get from
Well, I want to get rid of the mole. The mole's on the bottom.
So you have to put the moles on the top.
That's correct.
I see what you mean. Okay, yeah. So
1 mole of Fe3O4 is equal to 232 grams.
But there's joules.
Wait, we don't have cooking.
Good, we don't want them to cancel out each other. Because we need this in joules per gram.
My brain.
Does your mom do parent teacher conference?
No.
Look, remember, I do understand that conversions, you can actually go back and
hate
look at
that.
your conversions lectures. But conversions was in the first 9 weeks, I get that. But that doesn't mean we learn how to, lose how to do the process. We did numerous examples where we were converting a denominator and a numerator. You don't cancel out all the units, you end up with a unit on top and a unit on bottom. These are our desired units. And do we actually have a number here?
yeah.
Because it's gonna be 34.93 times 4.184 divided by 232.
0.629944.
Let's go to 4 significant digits.
6299.
Give him 22
6299
points
and
off.
then 4.
Yep.
Alright, so 6299, this is joules per gram times degree C. This looks really good. That looks like a specific heat capacity we're used to see. All right, good.
That's one confused.
I'm gonna look up the density of this as well, because I think this is gonna fit in a graduated cylinder. And if it does, we're gonna be able to, it's gonna be close, I think it is.
Wait, what? I don't know.
Wait, isn't it?
Oh, you broke. Woohoo!
That happens, it happens, it has no brakes.
Again. You just leave it there?
Show the quiet. Show the video.
It's a revolutionary.
So, we will be able to do a density,
Why is that so
no touching. We don't mess with broken glass.
That's a Bennett for.
Yep, Bennett. We pay you for a reason.
Bennett,
Oh, never mind. We don't pay you for a reason.
Do not lose your focus. What are you doing?
Do we need to move it?
No, not yet.
Alright, not yet, not yet.
All right, so we can do that, which is excellent. I'm going to give this to which group do you trust? We want a good.
Not us.
Anyone but us.
Bianca and Max.
Got you.
All right, let's see if we trust them.
Anyone but them.
Preston's immediately said, "Yeah, I do." How do we get a density?
Put in.
How do we do that with these two tools? Well, this one tool,
Throw it
really.
on the ground. See what happens.
No,
We know what happens already there.
Measure the glass first, then measure the rock.
A magic number pops up.
Extract it from each.
Very good. So we're gonna put a volume. We're gonna put a volume of water in here. It doesn't matter what the initial volume is. It just has to be enough to submerge the rock completely. All right. Then you will carefully, without allowing any of that water to go out, submerge the rock into the water. It will displace the water. That will give you the amount of space or the volume that the rock takes up. You will then subtract the two to get the volume. But that doesn't get us a density though. What else do we need? We need its mass. So we'll definitely have to take a mass before we do that. So here's what we're going to do. I will, these 5, I'm including you guys.
1, 2, 3, 4, 5. Okay, no, that's good.
Remember, it's reading the volumes. Silence. It's reading the volumes that ends up being difficult. So we do want a nice consensus of the initial volume. And we want a nice consensus of the final volume. Because the mass is going to be pretty easy to measure. As long as that scale says 0. Please make sure it says 0 before you put this on there. As long as it's 0, we should get a pretty accurate mass with the balance. All right. So, while I continue a little with this group, yeah, it would be fine. You're wearing shoes, aren't you?
Someone's just right across.
No, I'm in my bare feet. Like, bro.
Other than glass,
We just wasted $20 on glass.
Alright, let's go.
Break.
group, go. You should already been almost done. Hustle, hustle.
Give it to anyone
All
but
right.
them.
While they're doing that, I do need somebody to go and give me a good amount of water, just
Me and
regular
Bradley got that.
Compass Academy Pure.
Me, we got that.
Oh God.
And I need it up to,
We got that.
I want it up to about, just about the 400.
We got that.
Corner. Always get water. You gotta go upstairs.
Oh,
yeah.
You gotta put it in the teacher's lounge microwave.
Yeah, I'll probably just use that, but we'll let them move. It's good to move.
It gets our energy out.
So much. So much. Wow.
It's enough to.
They are not trusting. You're not trusting any dairy.
Regular water.
Water isn't a.
All right.
Okay.
By the way, this is a laboratory. You're going.
Yo, Brett, shut the crap up.
You're going to have to do the procedure. We've already done steps in this lab. I don't know how many steps you have written down already. But
Uh-oh.
Well, I was saying like this.
Step one.
Yeah.
we have a group that's already measuring the density of our unknown material that we believe is magnetite.
Oh, magnetite sounds cool. Mag.
Right now it's unknown. We believe
It's magnetite.
magnetite.
You mine it to make magnetite, remember?
So find the density of the rock.
You got it? Got that.
Confirm. Are we confirmed? What are we doing?
Word?
We don't need a mass of that.
Stupid is not the F word.
What was the mass of the water? I mean, of the rock. What was the mass of
Iron
that?
oxide. Iron quad.
Yeah, how did you?
No. And that's when she got it, and then she didn't answer, so I figured she got it.
No, that's what.
Density.
Stop.
Magnetite. Magnetite.
For the people who cannot spell.
Okay.
That's how I
Magne.
Okay.
Tite.
Oh.
Magnetite. Oh.
Density.
Yeah, what do you get, man? I check my watch all the time. That's kind of funny.
Okay.
Are we confirming? Make sure we're confirming.
What? How much did you pour the water?
Just say enough to submerge. That's not a big deal. We can. She'll give us all the. How about this? I'll put all of their data up when they give it to us.
Cool.
Okay.
All right. Those 5 are all working on the density data. They haven't given me any data yet. All right, they've roughly got the 400 mils. It does not have to be exact. Mr. Lesniak is now boiling, or at least heating up the water.
Yep. We got over 400, so we're pure, right?
This is Compass Pure.
Yes.
Yep.
All right.
Compass certified.
That's not, pure.
Oh, it's pure, alright.
Doesn't make any sense.
All right, so step 1 would be obtain the density of our unknown, or believed to be, magnetite. Would you forget an N?
No, an E for an A, an A for an G.
All right.
I.
All right, we think we got it? All right, here's our density data. What was the mass of our rock?
26.8
That isn't in the video.
Crap.
grams.
Was what?
26.8 grams.
0.8. All right, that's used a digital balance, so we do know that that's still an estimated digit at the end, but we're pretty confident. Did you take that mass more than once?
Yes.
Good. All right, what was the initial volume
The water.
of the water?
It was 45.2. I did 0.2, so it's a teeny bit over.
45.2. Did we get agreement with that within the 5 people?
Wait, this is the volume of the water. correct?
Initial volume.
The initial volume of the water.
All right, after you put the rock in, what did we end up with there?
52 grams. It's close to like on the line.
52, right on the line.
Yeah.
Do we have agreement on that?
Yes.
Rocky, Preston?
What?
I know you're agreeing, and I know
Oh, yeah.
you're not having a side discussion.
What if their side discussion is agreement? Whoa.
That's what I said. I know they're agreeing.
No, it's not. Holy crap, dude.
So it was 52 right on the line. 52 right on the line means 52.0 milliliters. All right. So we know that we'll need this difference. So the delta V.
7.8.
Not wrong.
Is Rhett ever wrong?
Rhett's never wrong. He's a perfect little angel.
Well, let's make sure that that's right, because we do have calculators to double check, because 7.8 doesn't look right to me.
Little angel.
Thank you. I don't mind you guys using your mental math.
That's stupid.
You're stupid.
In fact, I want you, I would, lie down, I would rather you use your mental math, but you should always, because you do get to use a calculator, double check your work, because we don't want to make a mistake like that. So we do have a volume, and we do have a mass. So our calculated magnetite density is what?
Wait, you got the 6.8 milliliters from subtracting 45.2 minus 52?
Yeah, I
Final
need to
minus,
subtract
yeah.
another 0.1.
Good one.
So this is going to be what?
How did you get that 6.8? Just. It's the 45 number minus the 52.
Thank you.
52 minus 45.
52, sorry.
10 perfect.
The density is 3.94.
3 point what?
94.
3.14.
Oh, Biden's working.
And this is darn, and look, this is not a bad volume. I wouldn't mind maybe one other group doing this. Why would I not mind one other group doing this?
It doesn't have to.
Because that will do what? We can get multiple trials. We should get somewhat the same result. So I'm gonna have one other group do this before we.
It's right, okay?
So who else wants to do this? We're gonna do trial 2. We'll do this group back here. So you 5, give me an initial volume in there. I'll dry this off.
Next tape.
Mega cow.
Oh, Biden shows me.
Oh, that's a big cost.
Where'd you get that?
You went in there for a paper towel. Oh, it's a rock. Oh, wait.
Valid magic.
I don't want to leave it on there too long.
Why are you
Would it go
leaving
boom
on
boom?
No, but
there? But it would be too hard to pick
it'll
up.
be too hot.
That's a lot of water.
You can't.
It's a lot of dirty water. That's like,
Touching.
that's borderline green/yellow.
Is it gonna change if you keep that? Is that one?
Put it on your phone.
No, I just want to make sure I get it as dry as possible. All right, get a good confirmation. Don't tell them what it is. Let them see.
Don't
it.
tell Dave.
Can you?
Lives inside a highway.
All right, someone give me a mass. Should be close to the same. Put it that way.
Back more. We're not that good.
I just think it's 3.9.
All right, so here goes trial 2. So we got a density of just about 4 here. Again, we do know the density of this compound. So we want to get it, hopefully get close, and that is close. Would you get?
26.94.
They got 26.9 in trial 2, which is
Yeah, 400.
it's very. Remember, the final digit's always estimated digit.
Oh my gosh, bro.
Data set 1, data set 2.
What is your third side?
What was our initial volume?
54.
You can't.
Right on the nose. I like it. We're getting, hey, look, getting pretty good data.
Yeah, good job, Bradley.
Oh, thank you. What?
I don't know.
What I did? What if we put coffee there? Wait, you said that.
We thought about putting coffee instead of water. Would that have been a good choice?
No, it's mostly water,
Oh,
mostly H2O.
so we made a good decision.
Yeah.
What do we got?
61.
Right on the nose again?
Wait,
Oh yeah.
maybe today.
And that is 7. This is coming out really good.
Oh yeah.
So it'll be a little bit lower, but not much. 3 point what?
1-4.
Nope, it's not gonna be pi.
Really, I want it to be Pie Day. Blaze Pizza gives away those free pizzas.
So what do we got?
Bennett, you were supposed to get the right numbers. Come on.
Bennett lock-in.
It was supposed to be the same.
Look, we're fishbowl today. Say hi.
Glub glub.
Oh,
glub.
we're just fans.
Oh, the kid waits back, guys. We won it.
What do we get?
3.84. What? Interactive.
3.84 or 3.8. So we're good.
They like to show us the best class here.
We got good.
That
We are
was
far from the best.
And remember, we do have. Go ahead and get my
Handy dandy calculator.
magnetite out of here by using the outside. All right. So this is pretty good. Now, is it the exact? No.
No.
So magnetite in nature, very quickly. Magnetite in nature, in the lab, has a 5.1 grams per milliliter density. All right, now look, that's not far away at all.
Oh, cool.
So in the grand scheme of things, this, we can say this with confidence, that this is probably not pure magnetite, which is fine because this rock was actually found outside.
Wow.
Like this is not store bought. I didn't order it.
Metal detector and just,
No, this was actually brought in by a student.
which,
I don't know. I don't remember. We've had it for a couple of years now.
Oh,
So we do know. And look, in naturally occurring substances, and you're going to have impurities, but that doesn't mean there's not a decent amount of magnetite in here. It could just be mixed with something with a little bit of less density, and that could bring an average down one. It's only off by 1 gram per milliliter. It's just over 1, so that's not bad. Now, on a percentage error basis, you're going to end up with about 25% error, but that's not terrible for a complete unknown. So this is unknown. We're pretty certain that our densities of this sample at least is around 4 grams per milliliter, right here, just under. And we know that pure magnetite would have that density. So I'm not saying we don't have magnetite. We just definitely don't have a pure sample. But so we are hoping to get, look, if we're right, and this has a good amount of magnetite in it, which it certainly acts like it, and it certainly looks like it, then we should get a specific heat capacity that's somewhat close to this. Because we did get a density that is close. So we're starting to get, I'll put it this way, I'm not disappointed with that result. I would say that this probably has magnetite in it. It probably just has some other things that have maybe a little less density. In fact, I would call this, upon inspection, heterogeneous, which means what?
I don't know, but it sounds like balance.
Sounds like a bowel movement.
We have these definitions already in our
let's
notes.
lose my black.
I can visually see that it has different parts.
Someone stole it.
So it's not all the same color. There's other things mixed in here. So yes,
Yes.
this is not pure.
are
Right.
we trying to find like the percentage of how much magnetite is?
No, we don't want to need to go down that road because that's a little more complex. Now, look, here's what we might do though. At the end of this investigation, we might actually look, and in fact, I'll offer some extra credit there.
I would love some extra. I could do that.
If, listen up, we obviously didn't get the density of magnetite. Are we pretty close? Yeah, these could easily be in the same family of minerals. And we know the specific heat capacity of magnetite, but we're gonna find the specific heat capacity of this rock. And that means you're gonna have a density and you're gonna have a specific heat capacity at the end of the day. And although we could always say, this probably is not a pure sample of magnetite, we can easily say that. And that's a great explanation. Why? Because it does look like it. 2, it does act like it.
And 3.
So it's probably just an impure, and believe me, magnetite has a lot of studies on it. There's different forms of it in nature that have different heat capacities. There's a form of it in nature that has one that's much, much lower. So this could be still it. But once you have all of this data, you can go kind of research and say, okay, what other magnetic minerals are there? What are their densities? And what are their specific heat capacities? Because there might be one that fits better.
So you said the extra credit would be finding the percentage of magnetite?
Find which one maybe fits a little better and prove it. It's not hard. There's other magnetic rocks out there. All right, so we need to get to a nice rolling boil, and here's why. Then let's start with 50 milliliters of water. I need someone to fill this exactly to 50 milliliters of water. We've already done something.
No, but we want to do more.
We're so good at
You can
filling
do
up
more.
water.
All right.
We're actually willing to
I
participate
gotta help.
once in a while.
How much water is in that?
Sure.
They went to the wrong place.
You said 50, right?
Exactly. You probably want a pipette.
What?
Emma, you're going to the
You're
wrong
probably
place.
gonna want a
Where
pipette.
you gotta go up to the
Look,
sanctuary.
here, you use this.
Oh
Use
my
this.
Oh no.
Gross. Look,
Here's the-
That is work up here. We need the one up there.
That looks
Fine.
He paid that.
No.
No, stop.
Go, go,
Yeah.
go.
Second
Water
round.
upstairs. I'm gonna go get better water.
We're good.
Nice try.
Always trying to get some. Here, you're gonna need this for perfection
How did we
purposes.
get away with that?
Okay.
We're the best.
All right.
Do you have a boiling plate?
While they're getting 50 milliliters of water,
I don't have a
we do know that the Compass mascot is the Yeti. Therefore, the only calorimeter we could ever
Hey,
use
that's a brand name.
is
They're
made
on YouTube.
That's fine.
You're gonna get
Maybe
$2
they'll search me out and ask me to sponsor there.
On a private.
We're about to make bank.
Yo, the cameramen make money off that, right?
Yeah.
Actually,
Anyway, Yetis, we do know work very good. You can pour your hot liquid or your cold ice water
That was cringe.
in your Yeti, and your ice is still there at the end of the day. Your hot is still hot hours
As
into it.
always.
So, in other words, this does a very good job at making the heat stay in the liquid. Well, that's kind of what a calorimeter is. So what I've created here, all right, I've added tape to seal this entrance in. I've put some insulation, some paper towel and stuff in here to be a little bit better insulator. We don't want to lose too much heat out of there. So I've sealed that thermometer in there. We can still read the thermometer. That's important. And it doesn't touch the bottom. I've got it so it goes perfectly.
Wait, he's destroying the cup. He's not getting sponsored.
I've got it so it perfectly goes into the middle so that we can just get the temperature of the water.
Does that look nice?
We can't be good enough.
Is it?
We were always good.
All right, so this is perfect.
Always good enough.
Check it. Check
That's
it.
us. Okay.
That is okay.
See, we would have done better.
It took like
Me and
it's
Bradley
okay.
would cook.
Wait.
You have it to the top. You need it to the meniscus.
What do you mean?
The what?
The meniscus?
Why does that sound?
The bottom line?
So you
That sounds
see-
like biology.
Oh, the
It
bottom
sounds
line.
like we're in the wrong
not the
class.
top. You have it 50 right on the top. But
Tisk, tisk, tisk.
you're actually
Yep.
at 49
Yeah, you do
exactly.
it.
Yeah, we would have
done
We
better.
would have done amazing.
Do you see that one? It
We'll
works
fix it.
perfectly
We got
fine.
you.
No, we don't need to fix it. We can be at 49 exact.
Me and Bradley can fix it.
Yeah, let them fix it.
But make sure we don't,
I'll get some pea water out of here.
when we're, just so you know,
Inappropriate.
Emma and Sophia, thank you.
Can I?
But we've already done this once. Let's make sure we do get this again. When we're reading our graduated cylinders, when we're reading them, that little bend on the bottom, it's called a meniscus.
That's just wrong.
That's where you read. You had it. You were reading right
That's
at the top.
biology students.
Right on 50, by the way. Perfect.
It wasn't very clear, but we got it now.
We get it now.
Oh, I got a good rolling boil. This is what we want.
Thanks to us.
Now, here's what we need to do.
Bradley.
I need to double check.
The boil can bowl. The boil can bowl.
Is this going to submerge my rock?
Shout out to Yeti.
Aren't you destroying their product? So why would they sponsor you?
Oh, shout out to Virginia Tech, just in case.
Shout out to
Dang, he's getting inducted.
I believe it
Oh
will
gosh, shout out to
completely
Duck.
submerge my rock.
and whoever made that shirt.
Wait, we're supposed
Shout out to Tina.
do we need?
Well, yeah, sure.
Dude, I should check.
Do we need to move the camera?
Duh.
Do we need to move the camera?
The experiment's happening there, so yeah. Why am I such a better cameraman, Carl?
Where do we get the brand deals?
Carl Marks.
No, Carl, Mr. Beast's assistant. This is Mr. Beast of Science right here.
The same song with an
I think you're overreacting.
No, it's legal.
I'm giving away 1,000,000 beakers.
All right. I need 50 mils to get it.
Don't mess this up.
I have to test
Shame
that.
on y'all. Shame.
In fact, wait, you ready? I would like 55 milliliters. You can do it.
5 more.
We don't need to leave.
Shout out to Yeti.
We love you, Eddie.
We love you. Looking for about $1 million a month. Sponsor.
I mean, even though we're destroying their cats, we still love them.
All right, we're doing great. So, I'm hoping you understand where we're heading with this. So, for your procedure purposes, what do you think I'm going to do? And then I'll correct that to make sure we're writing down what we actually going to do. We obviously first got the density to try to compare that to real magnetite. Now we're looking for the specific heat capacity to also compare it to real magnetite. But in order to do that, I need to know a few topics about this thing. In fact, what is the formula for specific heat capacity?
Grams times temperature.
So C equals energy or Q over mass times delta T. Well, we already got a mass.
Hey.
Not good enough.
By the way, let's go with, since we do have our, I was kind of,
That's good.
when you guys put just
Oh my gosh.
this in, 26.8 what?
8.4.
Well,
We told you that, but you said just do 26.8.
no, I never said that.
Yes,
You
you
go-
did.
Yes, you did.
Roll the clip.
Roll the tape. Get the tape.
You literally said, okay, so
Have you-
26.8. I said
Four tape.
26.84. You said just put 8. And I was like, okay.
All right.
He's right. He's always right.
So,
Coach Matt's always
He's the
right.
Mr. Beast of Science.
I don't know why I would say that, but it's
That
okay.
hurt. That hurt.
Let's
a lot.
go with a overall mass. We can take an average, and that does go down to the 100. So 26.85.
Come on,
Okay,
guys.
I think that's perfect.
Me and Oliver would never.
We're right on it.
I think so.
Imagine just like dump it all out.
That's sad. Shame.
You got the
Well
nod
done,
of
young
approval.
ladies.
We would have done better.
All right, we've put 55
We could've-
milliliters.
He would have passed out in shock at how good we did.
Mm-hmm.
All right, 55 milliliters of water is now in our Yeti calorimeter.
Okay.
Hey, you're adding mods.
I will now put the top on.
Shout out to
We'll,
Yeti.
we'll go
I'm
boom
going to
boom.
make sure, and it is, the temperature bulb is submerged, which is perfect. And we are now going to get an initial temperature of the water.
Oh, to see if like the rock heats it up or cools it down.
Well, it's going to heat it up.
You keep saying no.
Yeah, that's good.
What?
Is that good?
Yeah.
That's great.
Oh, Expo's in there as well. Shout out to Expo.
Shout out to Expo.
Crayola.
We already did
We'll go boom boom.
Ooh, will it go boom?
This is my Michael Jackson Science Club.
Oh.
Shout out to Michael Jackson.
Always give
Don't
a shout.
copyright
You're
us,
out
even
there.
if you're dead. Don't copyright.
We know you're out there.
Shout out Michael Jackson.
You're
Incorporated.
spending all of the time you could.
These videos are
Please
long.
don't
I would
sue
like
us.
somebody to come forward to get a Celsius
That's us.
temperatures.
No.
That's this, the one on this side. Tell everyone what the Celsius temperature is of the water currently. Somebody can actually do that.
Shout out to Great Value Distilled Water.
Shout out to whoever makes a white claw. That's all I remember that.
Anyone can come up.
Let's do it.
We did our.
Yeah.
Yep.
That's too
Now, if
scary.
you want us to go get more
It's gonna be really
water,
hard
that's
though. I
us.
don't know.
What coffee are you drinking, Mr. Beast of Science?
Is this
Decaf.
Celsius? Yeah.
Shout out to Decaf.
21 degrees Celsius.
Don't sue
Right on the
us.
nose.
What brand?
Yeah, Jack.
He said right on the nose. 21 degrees Celsius. So we want to
Come
say
on.
21.0. And it is right on the line. All right. Here's what I'm going to do. And I think you'll know why if we put our brains to use. I'm going to put this not.
This is the most
The reason I
dangerous
have a
experiment
heat
in
glove
science.
on is because I don't want to put it near the top and I don't want to put it on the bottom. I want to kind of put it in the middle. By putting this in the middle, what am I doing?
Allowing for the heat to feel good.
Good.
Wrong.
It's definitely cooler than the water. And so I should absorb heat into this rock. Now, the specific heat capacity of the rock, of magnetite, put it that way, is pretty low. I mean, it's not anywhere close to water. Remember, water is 4.184, so this is many magnitudes lower than water. But it did take a while for our water to boil and to heat up. So it's going to take a little while for the rock to make sure it's heated all the way through. But my
We need
question
to
to you is, why am I holding it into the middle of this boiling water?
The middle is the
So
best.
it's even.
So
Because it's hot.
I agree, the middle's probably the most even temperature.
Yeah, it's like
It'll be
water
cooler
circle.
near the top and warmer near the bottom.
Yeah.
But there's another reason. So I do agree with that.
Well, that's it, folks. We're heading to our commercial break.
No, think about it. Boiling water, and what we just learned about boiling water. What happens to water, at least in the water graph, when it starts to boil?
Oh. Wait. Evaporation.
Yes, it evaporates. I can't say no to that, but that's not what's happening on that
It
water
goes
graph.
flat though. Like it boils and it goes flat.
Ooh,
Sponsors are getting
Junior,
mad.
I'm loving it. Let's go with this.
Oh yeah,
It hits a
Sponsored
plateau.
by Hubby.
It hits a temperature plateau and stops. In fact, it actually stops at a certain degree Celsius.
100.
It stops at 100 degrees Celsius. So by me putting it in the middle of this liquid column, not at the top where it might be a little cooler, not at the bottom where it's right by the element,
It's
but in the
100
middle,
degrees Celsius.
I should probably be very, very close to what temperature? Yeah, because the temperature phase changes, we learned just recently, it doesn't just change. Water goes up to 100, it stops until all of that water goes up. So in other words, I can actually predict what the temperature of this rock is going to be. If I leave it in there a decent amount of time, which I currently am, and that's why I put this heat glove on, because it's hot. Even with the glove on, it's hot. So without the glove on, it'd be really hot. I'm going to give it about another 60 or 70 seconds. Till they're minute plus. Now, here's what I need someone to come up and do. I need someone to
Shout out Yeti.
take that top off of our calorimeter,
You mean our
and then
special.
as soon as I put that rock down in it, put the top back down as quickly as you can.
Sounds
we
like a
messed-
job for Taylor.
So,
Taylor's
got
not
Taylor.
paying attention. Taylor's
I feel like
not
we
locked
messed it
in.
up somehow.
that's true. If I end up burning him, I probably will be less in trouble.
Or red.
Me and Oliver would mess that up.
Actually, I'm not gonna burn anybody,
You
but
should burn red.
I don't know about that.
his mom and dad would go, what did Mr. Lesniak do again?
I'm just
Actually,
saying.
they'd say, what did Matt
There's
do again?
proof. And your mom's here.
I think it's about commercial break.
All right, Taylor, come on up.
Literally, our sponsors are getting so mad that they're not on yet.
All right. So,
Our sponsor today.
you go ahead and take it off. As soon as I put this rock back in, we want to.
Yeti, Hubby Dash, and GTA 6.
Hey, this is
Yeah.
on the video. Hey.
All right, we're going to do this transfer as quickly as possible.
We're looking for investors.
3, 2,
Duct
1,
tape is
go.
a potential sponsor.
Oh, potential.
Good. Excellent.
And
All right,
Virginia Tech.
start looking. Somebody,
Oh.
What are we looking for?
to any temperature change. Come on. Get up here. Someone's got to go.
Oh,
read
we're
this
looking
thing.
for sponsors. That's a job for me and Bradley.
Yep, of course.
That's right.
We're already up.
It's always a job for the hobby
Now we're up to
dash.
24. It's still rising.
Where'd you get a lollipop from?
And as soon as it stops,
You're such a probably from
we want the top.
I do want one.
Oh, shout out
temperature
Dum
already
Dum.
at 26.
Oh,
What would this be like?
please don't sue us.
It's a Dum Dum. We're shouting out Dum Dum.
Not quite made
Shout out.
27
Dum
yet.
Dum
but it's
gives me
rolling
Dum
up.
Dum.
The best flavor is the red.
Shout out Night at the Museum.
No, it's a mystery because you just live your life. Yeah, mystery. You live your life on the edge. Whoever made this water bottle, shout out to them.
Top.
Hey guys, are you wondering what coffee container we're using for this? Yeti, as always. Shout out Yeti.
Dismantled Yeti, but
Right. It has still been moving. We're in really good shape here. It is all the way now through 28 degrees Celsius.
Charlotte's like very invested in this. Charlotte's very invested in this.
Final temperature.
That's it.
Not holding a giant for
Good job, Peyton.
My final words are gonna be holding my beer.
All right, well, let's give it about
Oh, my
one.
bear.
Class, don't deteriorate, please. It
Shout out
has
Yeti.
slowed down its upward movement.
Wait, is that Nike?
Um,
Shout out Nike.
Did it ever reach 28? Because it's a little below it now.
Shout out to
It's
What are you doing then?
All right, she said maximum temperature hit the 28 degree mark. It looks like now it's a little bit under that. But we know that Yetis are really good, so it's gonna probably stay there for a
Shout
while.
out Yeti.
Shout out Yeti.
Looking for a major sponsorship at this point.
BT, we're always
So if you just
open.
make these
Look.
public.
They have to be public, believe it or not.
Yeah, after a certain
So Yeti, honestly, Compass Academy in Forest, Virginia, actually has a Yeti as its
Mascot.
mascot.
We're looking for $920,000
So-
for 10% equity.
And look,
What is
look at the science teacher.
Wow.
Use a Yeti calorimeter.
Ignore the duct
Use
tape
a
on top of
Yeti
it.
coffee cup. I mean, come on,
Shout out Decaf.
send some money our way. All right,
Everyone has been doing email me.
This might be the best video we filmed.
Oh,
all right, and I think, yeah, it's now just a hair above 27, so it is now starting to drop. Not by much though, Yeti. Well done.
Oh,
All right.
Hey.
So we got some really good data.
That's right. Shout out Yeti.
Now,
20K a month.
who can tell me, because I know you study, who can tell me what the key note is, superstar note, for understanding calorimeter and calorimetry calculations.
Shout out Yeti.
The heat lost by the
This whole
system
video is
or reaction is equal to the heat gain by the calometer.
duct tape sponsor.
Very good.
Guys,
So,
keep the chatter
the
going.
heat lost by the system is equal to the heat gained. I'm gonna go back on me. Let's go, camera people.
Oh, we're slacking.
That's okay. Yeti's sending us a
The heat
paycheck.
lost by the system or the reaction is equal to the heat gained by this calorimeter. The only place that heat can come from is that rock. The only way that water heated up was the rock. Now we're assuming the rock went in there at 100 degrees Celsius. That's a pretty darn good assumption. So the rocks, this again is
On
unknown.
YouTube.
The rock's initial temperature, delta T, is going to equal the final temp
Yes, I did.
minus the initial temp
Dang.
for the rock. Well, the initial temp was 100. Right on the nose. And the final temp was 28.
Is it rock
Shout out Yeti.
delta T?
Good job cooling that down. Yeti.
I'm gonna spam at Yeti on Instagram. Really sponsor us.
So,
Please feed.
we do know that that is going to be a minus 72 degrees Celsius. Always double check your work with the calculator. And of course it does need a decimal point, sorry.
You're not sorry.
Yeti's.
No, I grade you guys wrong for your sig digs, so.
Shout out Eyes on Jeans.
Excellent. And we're
Shout
gonna
out
need that
IT.
temperature. Because here's what we do know.
You've been going.
Oh my gosh.
This is what we know. It is huge.
Massive even.
This is a massive point.
Funny.
Energy equals C times M times delta T. Well, we don't really know the C yet, for this one. So that's what we're going to have to use
Yeah.
first of all to get the C. Well, we don't know the Q. So we don't know C or Q. We're in trouble, aren't we?
Wakanda forever.
Bad boys.
What are we to do?
Wakanda forever.
No. We do know something
Shout
else
out
in the
Chester.
system though. What else do we know? No. We don't.
Shout out Jules.
Here's listen up. So we're getting this. I didn't collect the homework on purpose because it sounded like there was some struggling going on. So I know I'll see a bunch of people at lunch.
Shout out Lon.
But if we could find one of these two things,
Wasn't that funny?
if we could find out one of these two things, then we could solve for the other. Well, we're certainly not going to find the C, because we know that that's ultimately what we're after. But is there a way to find the Q of what's going on? Q is the energy. Well, I don't know. According to Junior,
Shout out Junior.
Shout out
hey,
Yeti.
still at 27. Yeti's
Look at that Yeti.
Yeah,
All right.
shout out to Yeti.
I know, we worked so hard.
According to Junior, the heat gained by this Yeti calorimeter is equal to the heat lost by this system. Well, can we use our information that we know about this calorimeter to find out the Q? The answer to that is yes. And so here's what we got for water. That's right, we do have another substance. It's called Compass Pure Water.
It's a whole
Shout out
substance on
Compass
its own.
It's
It's a whole substance on its own.
Where does this H2O
I don't want to
take
erase
it
this
go?
one.
compass.
Shout out Brookhill Wesleyan Church. Check us out Sunday mornings
For
at 9.
H2O, the initial temperature, the final temperature was 28, of course.
I don't know if their service is at 9 or not, to be honest.
Are we supposed to do that?
My mom said Elton does a
That
nerd.
is so dyslexic, it's ridiculous.
Shame on Elton.
Initial
I don't
and
know
final.
what
No, that
Shame on
table
Elton for
element
wasting
is-
your mom's time.
Exactly. She's not paid enough.
Shout out to the Can I
I was
Lick
literally about to say
Sheet.
that. Oh yeah, shout out to the Can I Look at You. Great.
Thanks, Wikimedia.
The final temperature was 28.0 degrees Celsius. The initial temperature was 21, right on the nose.
Degrees Celsius.
And that is a temperature change of exactly 7 degrees Celsius. Well, this is huge.
Massive even.
This
1 minute.
1 minute.
Shout out 1 minute time.
This is huge. Why? Because now we know everything we need. Because we know the C of water is 4.184 joules per gram times degree C. We
Shout
know
out Jules.
the mass of water. You might not know this offhand, but the density of water is what? Does anybody know the density of water right offhand? Room temperature?
I unheard it.
34.
It's 1 gram per milliliter. In other words, at 1 gram per milliliter, if we put 55 milliliters in, then guess what? We have 55 grams. And last but not least, we have a delta T. Here's what your, it's not at home, it's at homework. We will finish up our lab, but I would really like for somebody to come in with our C, because with this Q, we're going to be able to substitute that Q in for this Q. Why? Because of Junior's note. The heat gained by the system is equal to the heat lost by the reaction, or in this case, the change.
Shout out Yeti.
All right. Cut.
That's a wrap, folks.
That is a